Half a day students, for today's lesson is actually a really quick one. We're going to be looking at quadratic equations when they're involved in word problems. Okay, so we're going to go over two different kinds: finding the length and width of a rectangle using factoring, and then finding consecutive integers using factoring. The first one we're going to go through is the rectangle problem. So here's an example of a problem where we're looking at factoring to find the length and width of a rectangle. The width of a rectangle is 3 feet less than its length. Its area is 28 square feet. Find the length and the width. So first of all, I'm just going to highlight or underline anything here that seems important. So already I can see that the width is 3 feet less than the length. Area is 28 square feet. And then I'm looking for length and width. So actually for me, once I see length and width, find the area or find the length and the width, I'm already gonna kind of box my answer just so I don't forget what I actually need to give at the very end. So I know I'm gonna have to find the length and the width. Okay, next I'm going to go into just writing equations based off of the information that I have. So I can see that the width is 3 feet less than the length. So when I say something is 3 feet less than something else, that means I'm going to be subtracting 3 from whatever it's less than, right? So I can say that W is equal to L minus 3. And just be careful with this, just because this is something, whenever they hear 3 feet less than, a lot of people mix this up. They kind of put W minus 3 is equal to L, but the width is 3 less than the length. So you're actually going to be subtracting 3 from the length. And since the area is 28 square feet, I know that area is 28, right? We should know that the formula for area is just length times width, right? So I can write 28 is equal to length times width. So what we always want to do is I want to make it, if I can, I want to only have one variable. And since I have a formula for W, I can now, since they're equal, I can substitute L minus 3 in for W, since that's the same as W. So that way I'll only have one variable, L, which I can solve for, because if there's only one, then I can solve for it. So what I'm going to do is take this L minus 3, and I'm going to plug that in there. So we have 28 is equal to L times L minus 3. From there, I'm going to solve this how we do in the last video, right? So I'm going to multiply it out and then put everything to one side and then factor to solve. Okay, so from here, I'll multiply it out. L times L is going to be L squared. L times negative 3 is negative 3L. And I'm going to move this 28 to the other side. So I'm going to subtract 28. So I have 0 is equal to all of these. Factoring. This one's actually easy to factor, thankfully. 0 equals factors of 28. That will give me a difference of 3. Is going to be 7 and 4, where the 7 is negative. You'll notice that we're doing a lot of factoring, right? So again, if you're not super comfortable with factoring, this is something that you need to review in one of the past videos or maybe some videos on YouTube, just because we're going to be using it so often. And from here, from the last video, I know that we can solve for L, right? So since L minus 7 times L plus 4 is equal to 0, at least one of these has to be 0. So my two possible values for L are positive 7 and negative 4. Okay, then this is where we're actually going to put it in the context of my word problem. It's the length and width of a rectangle. We cannot have a negative length, right? You can't say, oh, this chair is negative 2 feet high, right? So we're always going to look at length as a positive. So from here, I can say, okay, my length is not going to be negative, so I'm actually going to disregard that negative value of L. And I can already see, okay, I'm going to double check what my unit is. It's in feet, so my length is 7 feet. And if the length is 7 feet, I know W is just L minus 3, right? 3 less than its length. If I plug in that 7 there, I can find my W very easily. W is going to be, well, W minus, I misput this. This is going to be minus 3. My width is going to be 4 feet. And you have to make sure that you put the units there. Make sure it's the correct one. Okay, so at the very end, I always want you to think of, does this make sense in the context? Does it make sense to have a rectangle with 7 feet for the length and 4 feet for the width? Yes, that makes sense. If you were to get a really high number or a negative number, then that's where you might want to rework it and see if you might have made a mistake somewhere. Looking now at our second and last example, finding consecutive integers using factoring. So this is one that a lot of students skip. So many skip. I'm asking you, don't skip this. It's not too hard. If you just put in the work, this is all things that you know how to do. You just have to remember how to do it initially. Okay, so find 3 consecutive even integers such that the product of the first two plus 6 times the third is 152. So what we're going to do first, once I see this 3 consecutive even integers. So when we're talking about consecutive even integers, it means like 2, 4, 6, 10, 12, 14, 20, 22, 24. Okay, so things like that. They're in order. There's no skips and it's all even, right? So it's the same for odd 2. So what we're going to do is we're going to just call our integers, like our first integer. We can name it either n or x, right? So maybe I'll say my first one is going to be x. If my first number was 2, the next number I know is going to be 4, right? And how are those two numbers related? I found the second one by adding 2 to my first one, right? To find the third one, I'll add 2 to that, but I want to put it in terms of x, right? So that's actually just adding 4 to the first one, so I'm skipping the odd numbers. So this is nice because this works for both even integers and odd integers, where we have x and then one skips, we have the x plus 2, another one skipped where it becomes x plus 4. And from here, now that I have my variables or my expressions set for my first, second, and third integers, I can set up my equation now using whatever I have left in this sentence. The product of the first two, so the product of my first and second, I already can write that out. X times x plus 2. The product of my first two, x and x plus 2, plus 6 times the third, plus 6 times my third is going to be x plus 4, is, once I see is, equal sign 152. See, so it's not too hard to write that one out. From there, I'll just multiply it out, move everything to one side, factor, and then find the 3 different ones using my expressions here. So let's go do that. Distributing in x, we have x squared plus 2x, distributing 6 plus 6x plus 24 is equal to 152. Combining like terms, I'm left with x squared plus 8x. Okay, I'm going to have to subtract 152 to move to the left side. That's going to be 130 minus, that would be negative 128 is equal to 0. Okay, then I'll factor these factors of 128. That will give me a difference of 8. This one's a little bit more difficult, so maybe I'll kind of guess first and check on the side. 128, let's try dividing it by maybe 8. So 128 divided by 8, I have 1, 8, 48. Oh, this is actually nice. 16. So this is going to be, oh, and then it works out. 16 and 8 will give me a difference of 8. So it's going to be x plus 16, x minus 8. Okay, from here I'm given two values of x, right? Solving this, I have negative 16 and positive 8. Okay, and looking at the problem, I'm not done yet. So I'm given two possible x values. So this will actually give me two different sets of numbers. So again, it says to find 3 consecutive even integers, right? Such that this is true. So basically, this works for two different values of x. So what I'm going to do is going to find the two different, what's that called? The two different sets of 3 from negative 16 and 8. So if 8 is my first integer, then the next two following that would be 8. Oops, sorry. So we have 8. The even integer after that is going to be 10. After that is 12, right? For negative 16, the next one up from that is actually negative 14 because I'm starting from negative, right? So it's going to go higher. So it'll be negative 16, negative 14, and then negative 12. And then those will serve as our two sets of integers. So for this problem, the most important thing is really just that you set up your equation, your original equation here correctly. And from there, you should be fine. Again, basically this whole section, this whole topic, it's all doing the same thing. You're really just multiplying out, and then you're putting in standard form and factoring from there. Yeah. For this one, the only difference is that you have to interpret it using the question. So you just have to give the two different sets. So make sure you do that because it would suck if you did everything and then you just left it there, those two values of x. Make sure that you always look at the question again. Make sure that you answered that specific question. And in this case, we need two different sets of 3 consecutive even integers. That's it for today. Good luck. I wish you well. I think this is actually one of the good sections or topics. Yeah, so this Friday you have your test. I wish you luck. Let me know if you need any help with it. Not the test, but the topic.